Alright, students, welcome. Let's look at another question on triangles. This is a bit lengthy question. I want you to just go through it maybe twice, maybe more than that, and try to understand all the concepts that we are using here. Let's get into the question. Let's read the question first. Consider a parallelogram ABCD. You can see that triangle ABCD is a parallelogram. So parallelogram. The line AD is extended to point E. So this is one side of the parallelogram AD which has been extended out to point E such that the line BE, that blue line, bisects CD at M. Bisects the CD at M, meaning M is the midpoint of CD. M is the midpoint of CD. That means you can say that CM equals to MD. Both the sides are equal there. Now they are saying the diagonal AC is intersecting the line BE at point L. This is the L, point of intersection of these two lines. And we have to prove that EL equals to twice of LB. This is the question we have. Let's get into the derivation. I'll be using about 5 concepts here. Please go through them individually and systematically. You will understand it very easily. Let's get into the solution. Now, first concept I am going to use. In a parallelogram, opposite sides are equal. You see, ABCD is a parallelogram, and that opposite sides are equal. I am focusing on BC and AD. BC is opposite to AD, so they have to be equal. Let me write it. BC equal to AD. That's the first concept we are using. Now, let us go to the second concept. In the second concept, I will focus on this vertex. You see these two lines, CD and BE, are intersecting at this point M. So M is a vertex, point of intersection of these two lines. And we know that whenever vertex is formed, opposite vertex angles are equal. So this angle, these two angles are equal. Let me call it as X here. So let me write it. BMC, angle BMC, that is X here, equal to angle EMD, that is also X here. So that's a second concept I'm using here. Now let's go to the third concept. We know that BC and AD are parallel, and AD can be extended out to E. So the AE is parallel to BC. Because these two lines are parallel, I want to use the concept of parallel lines. In a parallel lines, and you have a transversal, you know that alternate angles are equal. So AE is parallel to BC and EB is a transversal. Whenever you have a transversal between two parallel lines, you know that alternate angles are equal. What is alternate angle here? AEB. You can draw a Z here. AEBC. So these corners you have, these are the alternate angles. Let me show that. So take them as Y. This is one angle, this is another angle. Both of them are equal. So CBM, that is one angle, this is Y, equals to DEM. I'm writing it this way. So this is both angles are equal. Let's call them as Y. That's the third concept. Now let's go to the fourth concept where I'll use the congruency rule. Whenever you have two triangles where two sets of angles are equal and one set of sides are equal, then they are supposed to be congruent triangles. So we use that rule. For that, let me focus on these two triangles. I've shaded them. One triangle is this DME, the other triangle is CBM. So let's focus on that. You see that this one set of angles X and X both are equal, and then another set of angles Y and Y. So two sets of angles are equal, angle, and then there is one set of sides. You see CM equals to MD. So there is one set of sides equal and two sets of angles are equal. So according to angle side angle congruency, they have to be congruent. These two triangles are congruent. BCM triangle is equivalent to EDM triangle. The moment we got that these two are congruent triangles, we can use the idea that corresponding sides are equal. The other angles are also going to be equal. So what are the corresponding sides? You see that here you take BC as a base here, and you see ED is the base there. ED has Y and opposite to X. BC has Y angle and opposite to X here. Opposite to X here. So BC equal to ED. That is what we get here. BC equal to ED or DE, you can write it. Order doesn't matter because we are just looking at length of it. But we also know that BC equals to AD. Already we have proved that in a parallelogram, opposite sides are equal. So BC equal to ED equal to AD. Now, knowing that, I want to find AE. Let's focus on AE here, the total side. AE equal to AD plus DE. We can write that AE equal to AD plus DE. But AD is BC and ED is also BC. Together it becomes twice of BC. So AE, this bigger line, equals to twice of BC. That is what we got to conclusion here. So we are almost there in the completion of this derivation. But remember this result. We are going to use it in the next equation here. Let's go to the final concept, fifth concept. Now I use the similar triangles rule. So in a similar triangle, how do you have so a similar one is a similarity rule. In a set of two triangles, if corresponding two sets of angles are equal, then they have to be similar. Let's focus on these two triangles. This yellow one is obviously a bigger triangle. This is a smaller triangle. They cannot be congruent, but we have to see whether they are similar or not. You see that already one set of angles are equal, y here and y here, and you focus on this vertex. So opposite vertex angles must be equal. That means this is also the set of angles, they are equal. So we got two sets of angles, angle equal. That means these two triangles must be similar. Triangle AEL, that bigger one, is similar to triangle CBL. So these two triangles are similar. The moment I got that these two triangles are similar, I can use that corresponding sides ratio must be equal. That's what we are going to focus on. That is the final step of this derivation. So we take EL by LB. That's what they're asking. EL by LB. The sides ratio must be equal to base ratio. What are the bases? For the bigger triangle, you have AE as the base, and for the smaller triangle, BC is the base. They are inverted. Okay. So AE by CB or BC, doesn't matter order. But remember, already we have got AE equal to twice of CB, this bigger one equal to twice of CB or BC. So if I substitute there, CB gets cancelled and you get the answer 2. So EL by LB equal to 2. You just do the cross multiplication, you will see that EL equal to twice of LB. So with that, the derivation is completed. Thank you very much.